So the two smaller sides have to be bigger, strictly bigger. Can't be equal to, have to be bigger in order for it to be a triangle. So if we do that math, we would have 31 is bigger than 21. If that's a true statement, it's a triangle, or it could be a triangle. If it's false, so if this was false, we'd go, not a triangle.
So is cute not an option?
Acute is right here.
Oh, how do you know it's cute?
How do I know if it's cute? So first we check to see if it's a triangle. So it is a triangle, that works, so this can't be an option. To check to see if it's acute, right, or obtuse, you have to pick your longer side, square it, and you're checking to see how that compares to 15 squared plus 16 squared. It's all about this symbol here. If when working through this, so let's go through this. I'm not going to do this problem, I'm going to let you do this. But if this was equal, equal means it's a right triangle. If this sign turns out to be greater than, if this symbol makes this work, that means our hypotenuse is too big. So that means it would be obtuse. If when solving this, it turns out to be a less than sign, then we would have an acute because that means our potential hypotenuse is too small to be a hypotenuse, so it makes it acute. So running through this one, can people help me with the calculators? 21 squared?
441.
441. What's 15 squared plus 16 squared? So do all the work for me. 15 squared plus 16. 481. So now is where I put the symbol in. So 441 is smaller than 481. So the only symbol that would work here is a less than symbol. Less than means this is too small. So if this is too small, it would have to be acute. The nice thing is small leading to acute makes sense to me. Small, acute, large, obtuse. If it's equal to, it's right. Okay? Yeah. 11. We have to realize that we have two right triangles. So I have two right triangles. Now, here's the thing. In order to use the Pythagorean theorem, I have to have two sides. So the first right triangle I'm looking at is that one with the 16 and the x on it, but I only have a 16 and an x. So that means I need to solve this triangle first to get to the next triangle. So our starting off point is this triangle here. Let's call this y. I'm going to solve for y first. Okay, so we know the hypotenuse, we're missing a side. So that means we're going to have 4 squared plus y squared equals that 4 square root of 5. Now I'm going to make sure I put the quantity symbol on there and make the whole thing squared. All right, 4 squared, that's pretty easy. That's 16 plus y squared. Now the hard part is, remember, it's everything squared. So it is 4 square root of 5 times 4 square root of 5. So that's going to be 4 squared, which is going to be 16, times square root of 5 squared, which is going to be 5. I'll say that again. So this I'm looking at is actually 4 squared times square root of 5 squared. All right, so that's going to give me 16 plus y squared equals 50 plus 30 is going to be 80. Subtract 16 from both sides. Y squared is going to equal, 64, which is kind of nice because the square root of 64 is just 8. So when I take the square root of both sides, I'm going to have y equals 8. So now what we really have is we just have a triangle that's 8. Looks like 16, and I need to find that x. That's just 8 squared plus 16 squared equals x, and I think you can go from there, right? Okay, good. Yeah, 10. Right next to it. All right, so what I'm going to notice is this is an isosceles triangle. Now, with our isosceles triangle, we also have a length that's the same. And notice why I'm bringing this up. We don't have to prove it or anything, but this would be that HL hypothesis that says that this is actually going to break it in half. So these two triangles are in fact congruent, which means that this segment is congruent to that segment, which means if the whole length is 48, This is 24, and this is 24. If you're not sure, just split it in half. Most of the time it's correct. So if you can't think of how you can prove it, just go, okay, the only way this makes sense is if I can use a right triangle, I must have to split it in half. Always a good bet that you split it in half. Or if you find this length, that you just double it to get that whole length. So now we just have to do 24 squared plus x squared equals 26 squared. Is that far enough, or did you struggle from?
That's far.
We're good?
Yes.
Okay, cool. What else we got? Yeah.
18.
18? 18. So we have a 17, a 3, and a 16, right? So let's first make sure that it can be a triangle. So I'm going to go, okay, that's my longest side. So to check to see if it's a triangle, we go 3 plus 16 has to be bigger than 17. 3 plus 16 is bigger than 17, so that's good. So I can just go, meh. Now I have a 33.3% chance to get it correct. That's a pretty easy check to narrow it down to those three, especially when it's not a triangle. Then it's like, boom, that's easy. All right, now that's my longest side, so I'm going to put that on the left-hand side. I'm going to say that's the one I'm checking. I'm checking to see if the hypotenuse is the right length. So I'm going to go 17 squared has something to do with 3 squared plus 16 squared. Can I get a little help on this one? Can we type in 17 squared in our calculator? Everyone should be doing this. Whether you're slow or 289, whether you're not the first one to get it done, just practice putting this stuff in. You'd be surprised how few times you guys practice it, you get to the test and you don't know how to enter it. Oh, are you working on something else?
No, I don't have it.
Oh, gotcha. All right, what's 3 squared plus 16 squared? Do all the work for me?
265.
265. So now, the only thing we have to decide is what symbol do we put in here? Well, they're definitely not equal. They're not equal, so it can't be a right triangle. Well, I'm going to say, okay, 289 is bigger than 265, which means I'm going to put this symbol. Even if you're not sure what symbol to put in there, if you're like, I'm on the test, I forget. Remember, the bigger one is the alligator eating, I don't know how you guys learned it. I learned it as Pac-Man eats once more. But you just have to know which one's bigger. That's bigger, and that was our potential hypotenuse. Our potential hypotenuse was too big. Too big means obtuse. All right, what else we got? Yeah, Grant. 12. Scott is using a 12-foot ramp to to help load furniture into the back of a moving truck. If the back of the truck is 3.5 feet from the ground, what is the horizontal distance from the ramp to reach the ground and the truck, blah, 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 round your answer to the nearest tenth of a foot. So this one we get to put in the calculator. That's nice. I don't have to do that stuff with square roots. But what we're kind of picturing is, let's do some great drawing. Almost looked like a cat there for a second. All right, there's his truck. A bed of a truck is usually up in the air, and he's taking a ramp. And that ramp is 12 feet. And it says that the ramp is 3.5 feet in the air. So it says that this height is 3.5 feet. We're trying to find what's the distance from the ramp to the base of that truck. So now we have a right triangle that I know two sides and I'm missing a side. So we're going to go 3.5 squared plus x squared equals 12 squared. I'm probably in my calculator going to actually go x squared equals 3.5 squared plus 12 squared. And now if I'm plugging this all in my calculator at once, I might want to take the square root of both sides, telling myself that x equals the square root of 3.5 squared. I'm sorry, it should be minus 12 squared, not plus, because I would have subtracted it from both. No, stop. Just stop. Don't listen to me anymore. That's not what I would have done. I would have did 12 squared minus 3.5 squared. I would have taken the square root of both sides of that. I would have had 12 squared minus 3.5 squared. It's nice to set up that way that we can plug it, especially because we're supposed to have graphing calculators. We're supposed to have those TI-84s. If you have a TI-84, this whole thing is really easy to plug in. Some of your scientific calculators is really easy to plug all that in, rather than plugging it in, getting a value, which is fine. We can plug it in, get a value, subtract it, and do the square root. But at the end of the day, we're taking the square root of whatever 12 squared minus 3.5 squared is. Is that far enough? Okay.
Is there a way to like check it?
What was that?
Is there a way you want us to like, check it?
To check to make sure you did everything right. Make sure it's a realistic answer. Like if I get out that this is 30 feet, that doesn't make any sense. If I get like a negative feet or something really small, it doesn't make sense. Let me look up the actual answer to that one. The actual answer should be about 11.5 feet. So I'm going to look at this and see if 11.5 makes sense in the context of this problem. If this is 12 feet, and that's the longest side, because it's the hypotenuse, this has to be shorter than this. 11.5 seems like it makes sense. All right, what else we got? Go ahead, Vance, yeah. 13. A 30-foot wire is secured to the top of a flagpole to a stake in the ground. If the stake is 14 feet from the base of the flagpole, how tall is the flagpole? Round your answer to the nearest tenth of a foot. So let's draw a picture. I have a flagpole. There's my flagpole. You can tell because there's a flag. Ooh, that was a bad flag. It's a flag. Trust me. It says flag right on it. See? It's a flag. All right, so we have a wire that's secured from the top of the flagpole to a stake in the ground. So here's my wire staked in the ground. So that's my wire. And that wire is 35 feet. Some jam happening somewhere. It's still jamming. Okay, they also give us what? Stake is 14 feet from the base of the flag. Oh, I'm sorry, I misread my problem. Make sure I go back and read that correctly. So it says a 30-foot wire is secured from the top of the flag. So the wire is 35. I read that right. I got thrown off by a phone going off. All right, flagpole is staked to the ground if the stake is 14 feet from the base of the flagpole. So that means this distance here, that distance from the flagpole is 14 feet. My job is to get the height of that flagpole. So we'd have like 14 squared plus x squared equals 35 squared. I think that should be far enough, huh? Mm-hmm. All right. My advice is on a quiz and test, draw a picture. That way if you didn't understand it correctly, at least I know what values you're looking for. Or if you're not sure what the circumstance is, raise your hand and I can explain it to you. At least I can help clarify a little bit. All right, anything else? That's it? All right, the primary thing of this lesson was honestly that you guys understood that last homework. Because this homework right now, basically the same, maybe a little more difficult questions, but it gets to the heart of, do you know this stuff or do you not know this stuff? And I'm going to tell you right now, so this is our second part about Pythagorean theorem. We will have 2 more lessons and a quiz. 2 more lessons and a quiz. So this is 50% of our quiz. We've already covered 50% of our quiz. And we just got back. Thursday. So 50% of our quiz is Pythagorean theorem. Now, you're going to notice our huge lesson here is just, what's the Pythagorean theorem? What's the converse? Just a quick rehash. But I think we did all of these within helping you guys out with your problems. So I'm going to skip to the one problem we're going to do as a group today, and that's solve for n. What did we learn? What did we learn on Friday? What shape did we talk about? Triangle, a right triangle specifically, right? This isn't just a right triangle, but here's my thought. Mr. Pabian taught us about right triangles. There must be a right triangle in here that I can solve. There must be a right triangle that's in here I can solve. So what we need to start realizing in a shape like this, the shape shows up a lot for Pythagorean theorem, so know how to deal with this shape. What I'm looking at is, what if I cut this right here? if I cut this right here, so that's my plan. I'm going to cut it right there. I'm going to say, well, Mr. Pabian talked about right triangles. What if I draw a right triangle? Maybe that can help me. Let's draw a right triangle. Bam, I have a right triangle. Not only do I have a right triangle, I also have a hypotenuse of the right triangle. Well, that makes you feel pretty good. I have a hypotenuse, I have a right triangle. But I have no more numbers on there. What's something I could put on that right triangle, though?
Full length of the bottom, right?
We have the full length of the bottom, so that's going to be the full length of the bottom of the triangle as well, right? Because we learned in first semester, these are parallel lines. In fact, we have two pairs of parallel lines. But parallel lines are always the same distance, no matter how far you go. So if you look at these windows, I know they're not open. Do you think if I measured this bottom blind, that would be sufficient if I want to measure the top blind? Yes. The bottom blind of a window is the exact same measurement as the top blind of the window. Just like in this shape, the bottom of the shape is going to be the same measurement as the top of the shape. So we're going to basically, what we're basically doing is we're saying, we're sliding that 14 up here. Bam. I got a right triangle. I have a 14. I have an n. But to use the Pythagorean theorem, I need side squared plus side squared equals hypotenuse squared. Yeah.
Well, if the whole side on the left is 60, and then you're inside the box, it'd be 9. This side of the triangle has to be 7.
Ooh. If this has to be 9, and this is 16, and I split this apart, this must be 7. Because 9 and 7 would give me that 16. Perfect. Now I have two sides in a hypotenuse. It's suddenly what we did on Friday. It is a squared plus b squared equals c squared. So now I'm like, oh, bam. 7 squared plus 14 squared equals n squared. Take a second. I don't want the individual things. I want to know what 7 squared plus 14 squared is. I want the entire thing. Don't shut it out just yet because that makes people stop. Get 7 squared plus 14 squared in your calculator, and then just wait for a second. Oliver is going to give us an answer in just a second. But I want to see that everyone does it in their calculator and gets the right value out. All right, Oliver, what'd you come up with?
245.
245 equals n squared. I would take the square root of both sides. And now I'm going to have n equals the square root of 245. Is there a perfect square that goes in 245? Don't yell it. Give everyone a chance. There is a perfect square that goes into it. So remember, if I'm checking for perfect squares, I'm checking, does 4 work? Does 9 work? Does 16 work? Does 25 work? Does, what did I get? 36. Does 49 work? Does... And we can keep going from there. You'll probably find it by then. So far? 49 goes into it. How many times does 49 go into it? Someone else. Yep, 5 times. So we're going to say n equals the square root of 49 times square root of 5. N would equal 7 square root of 5. Now, I want to specifically point out this question because I guarantee it'll be on the quiz, guarantee it'll be on the test. All right, you'll have one of these on the quiz, you'll have one of these on the test. If you don't know about sliding this side up and doing this, you can't even attempt this problem at 0 points out of 4. That's a tough pill to swallow when you know how to do the Pythagorean theorem. So make sure you know how to do these problems. In fact, if you look at your homework, not the first 6 are just determining if it's acute or something like that, but I think the next 2 or something have that sliding practice on there. I also would like to look at a problem with you guys. I forget which one. I'll go through it. I'll figure out as I do it. So what are we supposed to do? The lengths of the sides of the triangle classify. Each is acute, right, or obtuse. That's what we did in our last homework. These we're supposed to find the value of x. These are the ones where we probably have to slide that. This is a 3D shape. Might not look like it, but it's a 3D shape. It's like kind of like a pyramid that's pointing out at you. So you really have a bunch of right triangles. So for instance, I would have a right triangle right here. That right triangle has side lengths 8, a hypotenuse of 17, and a missing side. You probably have to find missing sides to get to x, because x, that triangle has none of them on there. These are all good problems. All right, I do want to talk about 15, 16, and 17, 18, because we'll all get different answers for these. We could. 15, 16, 17, 18 say find integers j and k such that A, the two given integers of j represent side lengths of an acute triangle, and B, the two given integers and k represent the side lengths of an obtuse triangle. So what they're telling you to do is first figure out what makes this a right triangle. So that would be 3 squared plus 4 squared equals 25. Now 25 is not your hypotenuse length. Your hypotenuse length would be 5, because that would be our 5 squared, or square root of 25. This might be a better way to look at this, that 5 is the square root of 25. When you take that square root, you find your missing side. So if it was 5, it'd be a right triangle. In order for it to be obtuse, it has to be slightly bigger than 5. I picked 6 to be obtuse. B is obtuse. To be acute, it has to be smaller than this 5, so I picked 4. So I picked 4 and 6. 4 is too small, 6 is too big to be a right triangle. So that's what you're doing on those problems. You first find out what would the missing side be if it's right, then make it a little bigger to make it obtuse, make it a little smaller to make it acute. On the surface, does that seem to make sense? Find your hypotenuse, make it a little small to make it acute, make it a little big to make it obtuse. In fact, I could have answered this as 4.9 and 5.1. Yes? Oh, sorry. Yeah.
What's the right answer?
I have the right answer on there. A would be 4, B would be 6. 4 would make, nope, you don't have to do this one. This one's done for you. I just wanted to have an example so you can look at it, because I'm going through it now, but by the time you're doing it tonight, you might have already forgot. Hopefully this is enough for that. All right, questions? All right, the rest of the time is actually for you to work on this. Kind of two ways to look at this. Do you want to start with the easy ones, or do you want to start with the hard ones? While you guys are working, I'm going to walk around and I'm going to check your homeworks as well. Yes, I figured that was your question. Yeah.
No, you're not.